talk a little bit more about similar triangles. So let's look at this similarity statement here. That is a horrible triangle symbol right there. Let's try that again. Triangle. So in the similarity statement, you really do need to look at that and pay attention to it. When we look at the two triangles, sometimes it's hard to tell if one is rotated or something, or flipped. It's hard to tell which sides and angles correspond. If they're close, you know. These two, they're rotated the same direction. They're not flipped or anything like that. So it's kind of easy, but I'll show you some later where it's a little more difficult. But this is telling you a lot. It's telling you angle D and angle M are congruent, right? Not kind of the same. They're exactly the same measure. Angle E and angle N, so angle E right here and angle N are congruent, and angle F and angle P are congruent. So it's telling you that, and then it's also telling you which sides correspond to each other. You know, we know that DE, so if we look at DE, that's 15, right? And then MN, that's 18. Those two correspond. So we could get our scale factor from that, couldn't we? Okay. In fact, well, if we do our scale factor, it's either 15 18ths or it's 18 15ths. I might like it this way if I were to do it, because I want to multiply 30 by something to figure out what x is. So I want to go from the big triangle to the little triangle. So I want a scale factor that's less than 1, don't I? So if I take this scale factor, which is 5/6, and I multiply 30 by 5/6, that's going to give me x. And if I multiply 24 by 5/6, it should give me 20, does it? Does 24 multiplied by 5/6, does that give us 20? So 6 goes into 24 4 times, and 4 times 5 works, doesn't it? Okay, so when I multiply 30 by 5/6, 6 goes into 30 5 times, and 5 times 5 is 25, so this one's 25. Now, is that completely crazy the way I just did that? Were you guys expecting me to do it that way? Is that the way you would do it? Got to go to the glasses on this one. Who's done problems like this before? Okay, so quadrilateral ABCD is similar to quadrilateral QRST. So you have to be told that they're similar. Do you guys usually find a scale factor and then say, what do I need to multiply 5 by to get Z? What do I need to multiply 6 by to get Y? Is that the way you do it, is you find a scale factor and multiply it that way? I see some heads shaking yes. See, I think maybe you might use proportions more often. So what I do is I look for something where, okay, I know the two are proportional, and then I look for this thing. Why am I concerned with the 8 and the 16? Yeah, that helps me find the scale factor, which, by the way, is either 2 or 1/2, depending on which way we're going, right? Okay? But, you know, I just use the scale factor. I'm going to say probably, you know, x. If I'm looking for x, I'm going to say x over, well, which side over here does it correspond to? 4. What does x over 4 need to equal? Be consistent. Go from the big quadrilateral to the small one, x over 4, and then look at the two you know. See, that's the key to the problem right there. There's your key right there. X over 4's got to equal 16 over 8. It has to be in proportion. So there's a proportion we can solve to find x. Now, we don't really need to in this case because the scale factor is just 2, isn't it? Okay, or, yeah, 2, the way we're going. What about y? Y over what? Yeah? I'm getting a couple people answering me over here. What's wrong with this half of the room? Y over what? 6? Okay. What does y over 6 have to equal? Yeah, it's still 16 over 8. See, that's still the key to our problem, is that 16 over 8. How about this? Which one haven't I done yet? Z? How about z over 16? Can I even do that? Z over 16? All you have to do is be consistent. So z over 16's got to equal 5 over 8. You notice I'm still using the key to the problem, the 16 and the 8, aren't I? Okay, I'm still using those. But I could have gone z over 5. That's probably the way we do it most of the time. Z over 5 equals 16 over 8. But you'll notice when I cross multiply, z times 8, z times 8, 16 times 5, 5 times 16. So that's the same deal. Okay, so you end up with the same thing either way. And this is the way we usually do it. We usually just set up a proportion, and then we solve it from there. And we don't worry about the necessarily what the scale factor is every time. Let's look at this one. So this is an altitude drawn on both of those triangles. And it's actually, these are isosceles triangles. That's 6, that's 6, that's 8, that's 8. These altitudes are going to have the same proportion as the sides. So if this is 20, we can find SP. I know it seems a little weird that those altitudes have the same proportion, but let me just show you. So I have a triangle, and then I have another triangle. I'll try to draw it similar. Okay, so if these two triangles are similar, if we draw an altitude in, what do you think? Are they going to be in that same proportion? Yeah, they're going to be proportional again. If we draw a median in, what do you think? Proportional or not? Yeah, proportional. If we drew a mid-segment in, what do you think? Yeah, proportional. So here we can find the proportion because now I always start with what I'm looking for. What am I looking for here? Come on. Okay. Over what?
Over
20. SP over 20's got, and then you have to think about what the key to this problem is. Now, is the key 8 over 6 over 8, or is it 12 over 16?
It could be either.
Could it be either? Yeah, it could be either. I'm going to say 12 over 16 like that. Okay? We'll talk about perimeters and stuff tomorrow. Okay, see ya. Oh wait, time! It's Tuesday! You guys suck. I know you were all gonna leave, weren't you? Kimball, he was like packing, man. Okay.
Teachers, we need to send the debate team to Mrs. Butler's room for a yearbook picture. Please send the debate team to Mrs. Butler's room for a yearbook
I
picture.
got a funny feeling none of you are on the debate team. Unless silence is a... No? Okay, so let's talk about perimeters, okay? So I'm going to draw a right triangle just to make things... Okay, so this is a 3, 4, 5 right triangle. So now I'm going to draw... hold on, we're still here. I'm going to draw another triangle that's similar to it. It's 6, 8, 10. So these two Pythagorean triangles are in the same family. This 3, 4, 5, 6, 8, 10. You could multiply here by 3 and say 9, 12, 15. They're all in the same family, aren't they? So we can see that the scale factor here is 1 to 2, isn't it? 1 to 2. Well, what about the perimeters? Let's look at the perimeter of our little triangle. 7 plus 5, that's 12, right? 12 is the perimeter of our small triangle. What about the perimeter of our big triangle? 6 plus 8 is 14 plus 10. Are the perimeters proportional? Right, they have that same scale factor for the perimeters as we do for the lengths of the sides. So we can use that to find missing pieces. Let's look at page 420. You guys get there? 420. All right. So example 4, you all looking there? Okay. A town plans to build a new swimming pool. Now an Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. So it looks like 25 meters by 50. Apparently though, this town either doesn't have a lot of space or not a lot of money, right? And they're going to build their pool, but they can only make it 40 meters long, but they want it to be proportional. I guess they're going to try to trick everybody into thinking that it's still Olympic size, right? So you still want it to have the same proportion. Gosh, how long or how wide is this pool going to be? Is it 20 meters?
Yes.
I think so. And if we work it out, I would always start with what I'm looking for. Okay, so I'm looking for this width. And then it corresponds, so this width over this width, what does it correspond to? And then I think about, okay, what's the key to my problem? And the key to the problem is always the sides where you know both of them and they correspond. Okay, the similar figures, it's not going to work if you don't know two different, one in each triangle, that correspond to each other. Does that make sense? Everyone got that? That's the key. So W over 25's got to equal 50 over 40? Got to equal 50 over 40. Okay, so 40 times W has got to equal 25 times 50. What is 25 times 50? Let's see here. That'd be fairly large. 25 times 50. Yeah, 1250. 1250. Divide both sides by 40. So let's see, that cancels out. And 125 divided by 4. 31.25. So the width of this triangle or rectangle is greater than the width of this rectangle. That's proportional. What's that?
I'm a little bit lost. That doesn't really make sense. Smaller though.
Isn't it? Shadow wants to know, isn't this one supposed to be smaller?
Yeah.
Well, apparently not. Math says it's bigger.
Wait, wouldn't it be 40 over 50?
Wouldn't it be 40 over 50?
Yeah.
So let's see, we made a simple little mistake, which I thought you guys would catch like right off the bat, but none of you were paying attention. Just letting me go. But let's say we make a little mistake like that. Are you going to get an answer that makes no sense at all and just put it down because that's what you got? Easton's like, yes, I am. No! If you know, that's what being a mathematician is kind of about. You gotta look at your answer. That can't be right. Don't just take whatever you get here. Make sure you're thinking about, you know, why this is, what's going on. So we should have got 20, shouldn't we? Yeah, we should have got 20. Let's see. Areas. We double the area of a rectangle, or sorry, we double the length of all the sides. Let's say we have a little rectangle here. It's 2 by 3. What's its perimeter? 10 feet, okay. 10 feet. We double that. So this is now 6 by 4. And the perimeter doubles. Okay? Okay, what do we have for an area here? Six what? Square feet. Okay, 6 square feet. What do we have for an area here? 24 square feet. So the perimeters are proportional with the lengths of the sides. As the sides change, the perimeter changes. What about the areas? Yeah, it has to do with this square right here. Okay? If we double the length of every side, 2 squared, this one's going to be 4 times bigger. If we triple the length of every side, the area is going to be 9 times bigger. If we quadruple the length of every side, what's going to be the deal with the area? Yep, 16 times bigger. It'll be 16 times bigger. That is something you'll see on the ACT. Okay, where they double the length of every side, and then they ask you about the area. What's going to happen to the area if we double the length of every side of this window or something like that? I've seen that a variation of that type of problem in a lot of places. Okay, I got one for you now. See if you've learned anything today. So let's have you do this one. Okay, so first of all, do you have enough information to find the 4 missing sides here? No? So if I give you this one is 13, do you have enough information now to find the 3 missing sides? Wait, and assuming is similar to QPT, SRT, assuming they're similar triangles, can you find the 3 missing sides at this point? Can you find X? Okay. But these two, no, you can't do that, can you? If I tell you this one's 18, can you find Y?
Yeah.
Okay, find those 2 missing sides.
Teachers, they need the debate team one more time, just where they were. They need the debate team to go back there just for just a second.
Are you guys agreeing with me? Did you all set up your proportions the same way as I did? Did you all start x over 13? No? Okay, did you go x over 14? Anybody do x over 14? I think we could do that. We could say x over 14 equals, what would x over 14 equal, guys? X over 14 would equal 13 over 10. Ugh, 13 over 10. That'd still work, wouldn't it? So I'm always going to start with what I'm looking for over the side that corresponds to it, and then, and of course, this is my key again. The 14 and the 10, they're the key, aren't they? So I'm going to be consistent. If I start with the big triangle, x over 13, then I'm going to say 14 over 10. If I start with the little triangle, y over 18, then I want to say 10 over 14. Does that make sense? So y is 12.86, x is 18.2, and what about the perimeters? Perimeter. You guys figure out the perimeter of the little one. What is it?
35.
is 50.2 over 35.86, still in this same 14 to 10 ratio. Try it. Check it. Are they in the same, is the perimeter in the same ratio as those two sides that are the key to the problem? Close. Why are they just close?
Because on the 12.86, we rounded it.
So right here on 12.86, this isn't exactly 12.86, is it? Okay, if we had rounded that further, then we'd be even closer. But, you know, what are we within? 1.39988. I mean, we're within 2 tenths, hundredths, thousand, 2 10,000ths. Really, we're within 2, well, yeah, 2 10,000ths. That's pretty close, isn't it? Okay, so we have that same proportion going on. All right, so we'll be doing this tomorrow in class. This is the assignment.